Yeah, hello guys, you're welcome to my YouTube channel, Mathematics Made Easy. So, you're welcome to my YouTube channel, Mathematics Made Easy. So, in today's video, we'll be looking into special rule. So, the great identity in mathematics and specifically in calculus. So, the question says, King's rule. All right, so proportion, so let f of x be an integrable function. We then have integral from a to b of f of x dx equals integral from a to b of f of a plus b minus x dx. Now, let's prove this first. All right, so let's prove this. Now, by proving this, we can let I be equal to integral from a to b f of x dx. Okay, so if I equals integral from a to b of f of x dx, now we can also make some substitution here. So we can say that let x be equal to a plus b minus t. Okay, then if we differentiate with respect to x and t, so we're going to have dx equals minus dt. Okay, so we're going to have integral from a to b. Now f of x will be f of a plus b minus t, then multiply by dt. Now, why do I have dt not having this negative dt? Now, remember, when we make this substitution, the limit is going to change. So the limit will change from b to a initially. Okay, so that will be, it's going to change from b to a. That is, if we substitute x to be b, so what are you going to have? You are going to have b here, so you have b equals a plus b minus t. Then you make t the subject of the formula here. You make the negative t the solid formula. Then if you do that, so you are going to have b minus b. So that one is going to give you 0. B minus b equals a minus t. Yes or no? Then this will be 0. Then you are going to have minus a equals negative t. Then you are going to have t equals a. That is, at x equal to b, you have a. Then also at x equal to a, you are going to have b. Okay, that is, you are going to have integral from b to a, then of f of a plus b minus t, then multiply by the negative dt. I get me now. Then if you use this particular rule, if you have integral from a to b f of x negative dx, so this is the same thing as integral from b to a f of x dx. So take note of that. So that's what happened here. That is, I'm having integral from a to b f of a plus b minus t dt. Okay, so that's what happened there. All right, so you can rewrite in form of x. So rewriting in form of x, that is, you can replace t with x. So you are going to have integral from a to b f of a plus b minus x dx. So we have our king theorem, or the king's identity. Okay, now that's the proof. So that's the proof of this king identity. Now let's look into some example. Okay, now let's look into some examples. So I'll go to the new page for that. Now, example. Now, example 1, we have evaluate integral from 0 to pi of x multiplied by sine x, then over 1 plus cos square x dx. So we want to make use of the king's identity here, or the king's rule. So I can call this integral, I can call this integral 1.0. Okay, so this is integral 1.0. Then if we want to make use of the king's identity, so according to the theorem, so we are going to have integral from 0 to pi, then so that will be what, pi plus 0 then minus x, so multiply by sine into bracket pi plus 0 minus x, then everything over 1 plus sorry, cos square pi plus 0 minus x dx. So this is going to give us integral from 0 to pi, then pi plus 0 will give us pi, so we are going to have pi minus x, then multiply by sine pi minus x, then everything over 1 plus cos squared pi minus x dx. So I can call this integral here integral 1.1. So this is integral 1.0, and then here is integral 1.1. So what we are going to do now is to add integral 1.0 and integral 1.1 together. So and then we can also let I be equal to this. So I is also this, so I will also be equal to this. So we add integral 1.0 and integral 1.1. So we are going to have I plus I is equal to integral from 0 to pi, then x sine x over 1 plus cos square x, then plus this, that is plus pi minus x multiplied by sine pi minus x, then everything here over 1 plus cos squared pi minus x, then dx. Now next thing you are going to do is to recall some identity here. Now we know that sine pi minus x is the same thing as sine x, and also cos square pi minus x is also the same thing as cos square x. Take note of that. Then we are going to have 2i, because I plus I will give us 2i. So we have 2i is equal to integral from 0 to pi, then x sine x over 1 plus cos square x, then plus pi minus x multiplied by sine x, then over 1 plus cos square x dx. Okay, so they have the same denominator, so the LCM will be 1 plus cos square x. So we are going to have 2i equals integral from 0 to pi, then we have our LCM to be 1 plus cos square x. So this will be x sine x, then plus. So if we open this bracket, pi multiplied by sine x will give us pi sine x. Okay, then minus x multiplied by sine x will give us minus x sine x dx. Okay, so this will be equal to integral from 0 to pi. Now x sine x minus x sine x will give us 0. So what we have now is pi sine x, then over 1 plus cos square x dx. Okay, so we are getting there. Now what you have to do next is to make another substitution here. So we can make substitution. Okay, so this is where we have 2i equals integral from 0 to pi sine x, then everything over 1 plus cos square x dx. Now let's make substitution by letting cos x be u. Okay, so we said let cos x be equal to u. So then if we differentiate, the u will give us minus sine x dx. Okay, so we are going to have minus sine x dx. Then so we are going to have 2i equals, so this is pi, we can bring that pi out, is a constant, that will be pi multiply by integral, so the limit is going to change. Okay, when x is pi, we are going to have that should be -1. Okay, cos pi is -1, and when x is 0, that should be 1, cos 0 is 1. So then sine x over 1 plus u squared. Now dx will give us, dx will give us minus du over sine x. Take note of that. So dx is now minus du over sine x. So sine x, we cancel out sine x here. So we are going to have 2I equals minus pi integral from 1 to -1, then of the u over 1 plus u squared. Now you remember that this integral is going to result to arctan of u. So you can check one of my video on that. So I prove the integral of the u over 1 plus u squared equal to arctan of u. So then we are going to have 2I equals -pi, now into brackets arctan of u, okay, then from 1 to -1. So we are going to have 2I equals -pi into brackets, then you substitute those limits, arctan of -1, then minus arctan of 1. Okay, so then arctan of -1 minus arctan of 1 is going to give us, that should be minus pi. Okay, arctan of -1 minus arctan of 1 should give us minus pi over 2. Minus pi over 2. So we are going to have 2I equals minus pi into brackets minus pi over 2. So don't forget, arctan of -1 minus arctan of 1 will give us minus pi over 2. Okay, now this is going to give us 2I equals, then minus pi multiplied by minus pi will give us positive pi squared. So we have pi squared over 2. Then you divide both sides by 2. So we are going to have I equals pi squared over 4. Now, therefore, integral from 0 to pi, then of x multiplied by sine x, then over 1 plus cos squared x dx is equal to pi squared over 4. Okay, guys. Now, so that's the answer to that question. So if you like this kind of video, please don't forget to like my video, subscribe to my channel if you are new, and then comment and share. Thanks. And also click the notification button so that anytime I drop video, you'll be the first to watch it. Thanks for your time. See you next time.